Okay, so you can see for 7b here, the question says approximate this cube root of 7 by using Newton-Raphson method. Initial value of 2 up to second iteration. It already tell you how many times you can substitute. 2 round only. 2 round only. Two interaction only. So you cannot do until you get the repeat. Alright, so follow the question. Iteration means the way you substitute and calculate. Substitute the first x, get the second x, then substitute the second x, get the third x. So the way you do that, that will be iteration method. So second only, up to second only. Okay, 2 round only you can substitute. So first of all, when you have Newton-Raphson method, you must have your function. So obviously you are not given a function, you're given a value here. So it means here you are finding a x that equals to cube root of 7. So we need to make it to a function. Alright, make it to a polynomial function. Bear in mind, don't move like this. Okay, when you move like this, it is in a square root function, cube root function. Cube root function, it will not the right function that we can use for Newton-Raphson method. Okay, so we have to make it into the polynomial function like quadratic, cubic. Okay, so for cube root, we move our cube root to the right hand side so that it will become cube function. So you can see x cubed minus 7, then it will be a cubic function. So our function that used for Newton-Raphson method, polynomial function, is a suitable function to use in Newton-Raphson method. Other than that, it might be have problem. Okay, so after we get our function, we need to differentiate so that power move to the front, power minus 1. Differentiate number 0. Then we can start our Newton-Raphson method, which is Sn plus 1 equals to Sn minus function over differential function. Then for the questions here, they say initial value. So our initial value means x1. You want to x0 also can, x0 also can. So x1 is 2. So continue to get x2 means I need to substitute 2 into our Newton-Raphson method. So our working should be right in clear, right in full working here. Then only we press our calculator, which is alpha x minus in fraction. Function is alpha x cubed minus 7 over 3 alpha x squared. So calculate for the first initial value, which is 2, equal again. So don't take fraction here. We are dealing in decimal, you can see. Okay, how many decimal in our calculation? So always refer to our question. They say 3 significant, so we will plus 2. Calculation must be more to avoid our rounding error. So 5 significant here. How to count 5 significant? 1, 2, 3, 4, 5. Okay, it will be 1.91666, so 6, 7. So 5 significant. 1, 2, 3, 4, 5. Here is 5 significant. So I already substitute 1 round. Okay, I already substitute 1 round, means I already done my first iteration. So I will going to substitute again, x3. Substitute 1967 into the function. So calculate 1.91. So press exactly what do you want to substitute here. 67. Okay, so we get 1.91 293 outside. So 29. So we will stop here. Alright, because of what? Because this is my first substitution, means first iteration. Here is already my second substitution, so second iteration. Question say you have to up to second iteration only, so I have to stop here. Yeah, so I have to stop here and I have to do our conclusion. What is our x? So stop here. So what is our x? Take the 3 significant, which is 1.912 at the back. So 2 at the back, we no need to round off. So therefore, 1.91 for these three significant figures. So this question a bit different than the normal question that we do in Newton-Raphson method. Normally we will do until we get repeating, but this question they say up to second iteration, then we have to follow the instruction from questions. So for this question, how we going to check our answer correct or not? Because you want to evaluate this one, correct? So you just press cube roots of 7. What is that? 1.91 something. Yes, that is very close to our answer already. So this is how we double check our Newton-Raphson method, whether we are doing right or not. So if you are going to evaluate a number, we just press our number. If you evaluate a function, then we just press this equation. Then we find for the function option here is shift solve to the equation.